Hello friends, welcome back to my YouTube channel. Today we will be discussing some important questions from electricity. They were asked in 2017 in October-November paper. Now let us see this first question. In this question, let us understand the question. This is a mass that is attached with this rope with the support of two pulley, and this mass is pulling a charge sphere of mass 0.8 gram, and this charge sphere is kept in between the electric field created by these two plates, and the magnitude of electric field is 2000 volt per meter, and also the charge is in equilibrium. Because of that, all upward force and downward force in this case should be equal with each other. Now let us see this, how the forces are acting here. The upward force for this mass is m into g, because this is acting in a rope like this because of this less mass, and the downward force for this sphere is m into g, that is this Newton. Now the charge should experience some downward force, because this upward force is more, and the object is in equilibrium. Object, in order to be equilibrium, the charge sphere must experience some downward force. Because of that, in this field, if charge experiencing a downward force, charge must be positive, because if this upper plate is positive, this should be positive in order to experience a downward force. Now our downward force will be for electron, for charge particle, our force will be Q into E. Our E is 2000 volt per meter. Now on balancing this force, total upward force is equal to total downward force. Our magnitude of charge will be 5.9 into 10 to the power minus 6 coulomb. That is in our option choice. That option is in our option choice C. 5.9 into 10 to the power minus 19 coulomb are in A and C, but the charge must be positive in order to be equilibrium. Because of that, our option choice C is the correct answer for this question. Now let us move to question number 32. In this question, this is electron. This electron is entering in this electric field. If you see this electric field, this part must be positive, this mass must be negative because of this arrow. If the electron is just entering in this field, because of this positive polarity of this plate or this side, the motion of electron will reduce, motion of electron will decrease, and then will decrease linearly back. They will decrease linearly back. Because of that, our option choice C is the correct answer for this question. They will not get sufficient field in order to make the parabolic or in order to make the curved path, so they will slowly move back. Now let us see question number 33. In this question, the electric current is 3.2 into 3.2 into 10 to the power minus 3 ampere or 3.2 milliampere. Now we need to find what is the rate of flow of electron. Our formula is I is equal to Q by T, but Q can be expressed as NE. Because of that, our formula is I is equal to NE by T. Current is clearly given here, and we know value of E, 1.6 into 10 to the power minus 19 coulomb. Our required answer is N by T. N by T. On solving this, I divided by E, we will get our answer. I divided by E is our answer. That will give rate of flow of charge, and that will be 2.0 into 10 to the power 16 per second. That is in option choice A and C. Now if we see the direction of electron, it will follow from y to x axis, point y to point x. Because of that, our answer choice C is the correct answer for the question number 33, from y to x, and magnitude is 2.0 into 10 to the power 16. Now let us move to another question, question number 34. In this question, a filament lamp is there whose resistance is 180 and current is 500 milliampere. In the case of current and resistance, our formula for power is P is equal to I square R. If we write I 500 milliampere, on converting that into ampere, and if we write the value of R here, we will get our answer, and our answer for this question will be 45 watt, option choice A. Now let us move to another question, question number 35. In this question, this is one copper wire and this is also another copper wire. because of that our resistivity will be same. If the wire is not changing, if we are using the same wire, then resistivity remains same. And the important information given here is the volume of this wire X and volume of this wire Y are same. Because of that, now let us see some modification on our standard formula. Our standard formula is R is equal to rho L by A, where rho is the resistivity, L is the length of the wire, and A is the cross section area. Now if I multiply L on both sides in numerator and denominator, the lower part will give us volume. Lower part will give us volume. Because of that our expression for R will be rho L square by V. And now in both the cases our volume is constant. Because of that resistance in X will be rho L square by V, and resistance in Y will be rho into 4 times of length, square of 4 times of length divided by V. In Rx it is rho L square by V, and in Ry it is rho into 4L square by V. Because of that 16 will come here. On comparing or on dividing this, we will get Ry by Rx is equal to 16. Let us see, Ry by Rx is 16, that is in our option choice D. So option choice D is the correct answer for this question number 35. Now let us see question number 36. In this question, previously this circuit was open. Now we are closing this circuit. If we are closing this circuit, then electron will flow from this path, because electron always choose the path in which there is low resistance. If we compare this, the resistance of this will be low because this is only a switch. Because of that more current will flow in emitter. Because of that, and current in emitter will increase. Now potential drop is not there in this resistor. Because of that voltmeter reading also increases. All potential will be dropped here. Because of that our answer will be option choice B. Both reading of current and reading of voltage will increase in this circuit. Now let us see another question. In this question we need to take care of one thing. In order to apply Kirchhoff's second law, we should see the closed loop. This is one closed loop, this is another closed loop, and this outer loop is another closed loop. In this 3 loop we can apply Kirchhoff's voltage law. If we see option choice D, it is sometimes saying E and then again I1 R1 and again I3 R3. It is moving up down in all loop, so it cannot be our answer. Option choice C also cannot be our answer. If we see option choice B, option choice B is using Kirchhoff's second law in this loop. It is taking this I2 R2 positive, and it is taking this, because of direction of this current, it is taking I3 R3 and I4 R4 negative, and there is no power supply in this loop. There is no EMF in this loop. Because of that I2 R2 minus I3 R4 minus I3 R3 is equal to 0 is the correct answer for the question number 37. So option choice B is the correct answer for question number 37. Now let us move to question number 38. In this circuit we need to find the condition at which the voltmeter reading is 0. Voltmeter reading is 0. Voltmeter reading will be 0 if potential at P is equal to potential at R, or if potential at Q is equal to potential at S. If they are at same potential, then there will be no potential difference. Because of that voltmeter reading will be 0. Now let us see this. If we see this, if we use the potential divider formula, the potential at P will be resistance P divided by P plus Q into E is the EMF. Now if we calculate the potential at R, the potential at R will be the resistance R divided by total resistance of this line R plus S into EMF E. Now the voltmeter reading will be 0 if these two value of potential at P and potential at R are equal. On doing this and on solving this, we will get QR is equal to PS or PS is equal to QR. That is in our option choice D. Because of that our option choice D is the correct answer for question number 38. Thank you very much. All the best.